Release the Kraken!
Welcome back, fellow game designers. In our last few videos, we went ahead and created our little top-down dude with some jumping and double jumping, which is cool. And of course, we can open a door, close a door. Hooray! In this one, we're going to take a look at how to set up the character animations using the visual state machine. Now, if you have not yet done the Elf Dude and Mario video for importing a character, I recommend checking that one out first, because I'm not going to go over that in this video. But assuming you have those, so some things that may be new, if it's been a minute, I have an animations folder. I've moved the environment set pieces into an environment folder within animations. I've got an Elf Dude folder inside of animations and a Mario folder inside of animations. We're going to need those in a little bit. Materials we've had before. Inside of the prefabs, we have our door prefabs. We also have the Elf Dude and Mario prefabs. We'll take a quick look at those in just a minute. We also have a textures folder that is new with all of the Mario textures. But of course, if you did the Mario and Elf Dude tutorials, you should have that just fine. In the skeletal mesh folder here, which is also new, we have a Elf Dude and Mario folder with their assets in them. So let's go ahead and get started. I'm going to go into my prefabs folder. Let's go ahead and do Mario first and double click that. We can expand Mario. We have all of his pieces. And then inside of there, we have Mario's hat and hairpiece attached to the head. And I just have the hair toggled off. So you can switch these out if you want to, whichever one you want to use for your character. Okay, go ahead and just minimize that. So what we need for this is an animator. So we want the animator to actually be on our model, not the parent object. And the reason for that is Unity actually checks the child for the animator, but it doesn't check the grandchildren. And you can see the root is actually a child of the bind pose object, and the bind pose object is a child of Mario. So that makes it a grandchild. Unity doesn't search more than one level down. So we need to put our animator on this. So I'm going to come over to Add Component, and I will go down and just Animator. Type that in. There it is. Now this does require a controller, so I'm going to jump over into, the animations folder, and I'm going to open up Mario, and I will create a animator controller. So right click, create, come down to animation, and make an animator controller. I will call this Mario controller. And I want to attach this to our animator controller over here. So animator controller, hit the drop down, and you can see I have the hinge door if you've made the door before, and I also have Mario's controller. So I'll get Mario controller, make sure that's added to that. Okay, let's go ahead and import the animations. So I'll open that up. And I went ahead and just rename this stuff to organize it better. So we have our skeletal meshes here. And we have our animations here, all prefixed with the anim underscore. Let's grab those and drag them in. Okay, so here they all are. When you import these, there's a parent object, and then of course if I open that up, there is a root component with a transform, and then the actual animation file here. So this one is the Mario walk. So I'm going to get the take from that, Control D to duplicate, and I'm going to name this whatever this root this original one was. So this was Mario walk. So I'll right click on that, rename Mario walk. And then I can just remove the original. So I'll get the original Mario walk and hit the delete key. Yes. And I'm just going to repeat that for each one of these. I'll grab the next one, expand it, duplicate its animation, and then rename it. So this is the Mario Run, So I'll rename Mario Run. And then I will delete the original. This one is Mario Punch. I'll get the take for that. Rename Mario Punch. And then get rid of the original. Voila! And there we have all of them extracted. Go ahead and open up the Animator controller. Just to navigate in here, you can middle mouse click and drag. Left mouse click lets you pick things. Right mouse click lets you open menus. I'm going to come over and get this exit. I'll just pop them up over here. So we want to create a state. So I'm going to go ahead and just right click to create an empty state. This will be my idle, so I'll name it idle. So with my idle, I'm going to come over to motion and hit the drop down, and then I can pick my animation out of here, or I can simply drag my animation from my menu here into that. So where's my idle? There it is. I'll drag that into the motion slot, and now those are connected. Hooray! Pretty easy. However, it can be a lot simpler than that. All I really have to do is take any of these animations here and then drag them in to create a whole new state. Now I do want to keep the names pretty consistent when I search for them, so I'm just going to name this walk here. And you might be like, well, why would you do that and name these ones Mario Walk? And that's in case if I search for the menu, I know what they are, I have an identity for them. But inside of the state machine, if we ever have animations that are repeated across other characters, I can grab Mario's walk, right, just by calling walk. So I can go, Mario, play walk. And Mario goes, okay, and plays walk. Or I can go, Elf Dude, play walk. And then Elf Dude goes, okay. But if I have to specify Elf Dude, play Elf Dude walk. Or Mario play Mario walk, and then Scorpion play Scorpion walk. It becomes much more tedious. So I find that in the state machine, it's a lot nicer if we are consistent with our names. Now to connect our walk, we want to be able to transition from idle to walk. To do that, just go ahead and right click and make transition. And then I can go ahead and aim it to my walk. And there we go. So now I can go from idle to walk, and we have this transition line. To get there, if we select our line, we have some options. So we have an exit time. This is basically waiting for the animation to finish before transitioning. We could do that, but we really want to be able to go from walk to idle or idle to walk back and forth pretty quickly. So instead of letting the animation finish, we're going to give it a command and then we can exit. So I'm going to go ahead and say no on exit time. You can see down here it says a transition must be set. So right here we have a list of conditions, but that list is empty. Where do I get them? Well, over here we have our layers. This is for animation layers. We'll get to those later on, but right next to that is the parameters. So your parameters are going to be the conditions that you can set from your code and talk back and forth to your visual state machine. So I'm going to hit the drop down here, and we can pick a value option. So for us, we will very simply choose a float and use our movement speed to determine whether or not we're walking or standing still. So I'm going to hit float. I'm going to call that speed. I'm going to keep it all lowercase just to stay in Unity's naming convention. We have a value of 0. And then over here, I'll hit the plus sign. And now you can see that it grabbed our condition. And we want to transition to walking if our speed is greater than 0. good enough. Now you can change this. You can make it 0.1 or whatever, but I think 0 is going to be fine. We also need to be able to get back from walking to idle. To do that, I'll make a transition. So right click, make transition, and we can aim that back to idle. Go ahead and select the new one. And once again, we want to be able to exit walking pretty much immediately. So I'm going to say no for exit time. And then down here, I will add my condition. We're going to use our speed again, but this time we want it to be less than. Now, since our speed value can go in negative directions, having a value less than 0 wouldn't work because you could be -1, right? -1 is less than 0, but you would still be moving in that direction. So here, I'm just going to do -0.01. I think that's far enough. You can make this number lower if you like, but I think 0.01 is fine. All right, so now we got to go and test it. Before we can do that, we have to finish setting up Mario. So jump over to your scene view here, and make sure you are in the Mario prefab. Go ahead and select Mario, and if we take the model here, you can see that we already have an animator set, but we need to set up all the stuff that is on our player. So I need that, make sure we have the Mario main object, and we want a character controller, because that's what we're building with today. So there's that. Let's go ahead and size this up. So up here on the little compass, let's go to a side view. I'm going to hit the little red arrow. That's going to turn me to the side. Hit the middle of the box. That's going to square it up for us. This is going to give us a nice orthographic view. Now we can dial in our capsule. So for center, I can hover over Y and drag to adjust my center. And I think 0.69 is good. Radius, let's see. Let me grab the radius and just dial it down. I like, let's see, 0.28. I think that's good. And then for the height, let's get that low enough. We want to get it to where the bottom of the capsule is at his feet and the top of the capsule is at the top of his head. So 1.39 looks pretty good. All right, I'm going to hit the center of that again. That's going to bring us back into perspective so we can see Mario in all his glory. All right, go ahead and add a component, and we will add on our script. So I'll do player movement. And our player movement needs to have our character controller. Let's go ahead and drag that in. And then the animator, that's on the Mario bind pose model. We can grab that pretty easy. So in the animator, hit the drop down and just grab that. Go ahead and hit the little exit button over here. Let's hide the default player. I'll go ahead and just click the little button here. And we'll bring Mario into the scene. And I'll just set his position to 0, 0. So now Mario's in the scene. I'm going to go back to the animator, and we need to make sure that our animator is going to be talking to our script. So go down to your player movement script. In here, we need to get a reference to our animator. So up at the top here, I'm going to make a public animator, and I will just call it animator. Let's go ahead and talk to that. Let's go to our player move player function. Inside there, we have our player movement section here where we actually move the player. Let's go just before that. Make a new spot. Let's call this set animator values. And all I want to do here is get the animator and then dot and then call the set float function. So what set float does is it grabs the float parameter that we've created. We pass in the name and then the value. So just make sure you are passing in the name of what you made here. So we called this speed. So that gets a set of quotes, speed, comma, and then the value you want to determine how fast you're going. So in this case, we already have our move direction to determine our speed. So I'm going to do move direction. Now move direction is going to get mad because this is a vector, and it says, hey, we can't convert a unity vector 3 to a float. Well, remember that a vector is 3 floats, and we need this to be compressed down to 1 float, so we can just get the magnitude of that. So I'll hit dot, and we'll get the magnitude. There you go. So this will return the length of the vector, or its magnitude, and then this is going to be an absolute value, so you don't have to worry about the negative situation. This should handle that for you just fine. Go ahead and hit save, jump back into the game here, and hit play. So there's Mario, and you can see he did his idle, and he does take a step when he walks. But you can see he stops walking after a few seconds. Go ahead and hit stop. Go to your animations. And let's grab the walk. Make sure that we check loop time. That's going to make sure that our walk continues over and over and over again. We'll do the same thing for the run, as well as the idle and the fall. So again, walk, run, idle, and fall. Just make sure loop time is checked. Go ahead and hit play. And you can see idle keeps going, and walking keeps going. And if I stop, he stops. Now we do have a little bit of an issue with the camera not following. That's pretty easy to fix. Go ahead and hit stop. Grab your top-down camera, and in the object to follow value, right now it's set to player. Let's go ahead and make sure that that is Mario. So I'll grab that and drop him in. There we go. Now the camera follows. Hooray! Now we can jump, but we don't have really an animation for it. So let's go ahead and set up jumping. Go back to the animator. And let's get our stuff. Yeah, we'll get our jump, and then our fall, and our landing. We'll grab those. So we'll make a transition from idle. Right-click, transition. And go ahead and pick your jump. And then we'll go from jump. We'll make a transition. We'll go to falling. And then falling, we'll transition into landing. And then landing, we'll go back to idle. So we have a little cycle here. Let's go get the transition from idle to jump. Now we want this to be immediate, so we'll go ahead and just say no on the exit time. But we do need to set a condition. So we'll just say if we are jumping. So I'm going to go ahead and hit the drop down here. Let's make a bool. And we'll do is jumping. Cool. Over here for conditions, we'll add that. So get our jumping variable. And if it is set to true, then we will enter the jumping state. Now we're going to transition into our falling state. So when do we want to transition into falling? We'll do that once this animation finishes. So we won't set a condition, we'll let the animation finish. And you can see that it'll naturally blend over into our falling animation, which is really nice. It means that we don't have to set up additional transitions. It'll try to smooth that out for us. So we can leave that one alone. We're going to go from falling into landing. So falling, since falling loops continuously, we want to be able to exit it whenever we need to. So when the moment we hit the ground, we stop falling. So we're going to say no exit time. Instead, we will set a condition. That condition is going to be when we hit the ground. So let's go ahead and make a Boolean. This is going to be is grounded. And we will add that here. And if grounded is true, then we will perform our landing. And then to go back to idle, let's get our transition. We are going to not put anything here. we're going to let landing finish. Let's go ahead and save that. Come back into the code. We'll go back to the top here, and let's make those variables. So let's make a private, we'll do a bool is jumping. We'll set it to false. To set this, we're going to scroll on down, and we need to put our is jumping variable in a couple spots. So here, when we hit the button to go into our jump state, we're going to go ahead and set is jumping to true. If we hit the ground, so in our grounded state, we will set is jumping to false, and we will also turn is jumping off if we are in our falling state. So I'm going to go ahead and just add a brace. So enter there, add a brace, and then I'll get rid of the back brace, enter, add a closing brace. And if we are in our calculate gravity, we will say jumping is also false. So is jumping false. Let's go ahead and set this on the animator. So animator dot set bool. Since we are setting a Boolean variable this time, the bool we're going to set is going to be is jumping, and we will simply pass in the is jumping variable. But what do we do for our grounded variable? Well, that one's pretty easy. We'll get the animator, set bool, and we're going to say is grounded, but we never set up an is grounded variable. Conveniently, our controller already has one, so we'll just pass that one in. So controller dot is grounded. We can go ahead and save that. Come back over into our game, hit play. Alright, so Mario can walk. If I hit the button, Mario jumps and he lands. Jump, land. Look at that. He jumps and lands. Of course, I have double jump, so I can jump in the middle. But once we've successfully hit the ground, that's good. Now if I'm walking and I jump, nothing happens. And if I am up on like a hill and I fall off, I never enter my fall state. So let's go ahead and set it up so that when we fall off an object, we can go into our fall state. And of course, we want to be able to jump while we're walking. So I'll hit stop, go to our animator, and pretty easy. To fall from idle, all we're going to do is make a transition from idle to fall. And that transition will be if we are not grounded. So let's make it so it's instantaneous, and then add our value if grounded is false. Now we also need to be able to enter falling from walking. So I'm going to right click from walking, make transition. Go ahead and hook that one up. Now you can see as we're building this visual connection, we're getting a web of spaghetti, which can be a bit daunting to look at. You'll get used to it. I preferred to do this all in code because I don't like the spaghetti, but you might appreciate the visual state machine. Anyway, to go from walk to falling, we also want to set the condition. So we'll do it immediately, and it'll be the same thing. Let's make it when we are not grounded anymore. So grounded, false. Go ahead and hit play. Now Mario did a bit of a pop there, and the reason for that is we're applying gravity all the time, and our character controller has to move a little bit before the gravity value kind of kicks. One of those little quirks, but we will live with it. Let's go ahead and take a step off, and there he goes. He's entering that fall state. We also want to be able to jump from walking, so I'll get my walk, make a transition to jump, get my transition line. Same deal, we will turn off the exit time, and we will just set this to if we are jumping. So is jumping is true. So now if I'm walking, I can jump. Now when I land, you can see Mario slides a little bit and then he starts walking. So we need to be able to set the transition so that whenever we hit the ground and we are walking, that it just goes into our walking state. You can always set up an animation to where you have some impact and he has to take a step first, but that's beyond the video. So we'll just go ahead and make our transition from landing to walking. And our transition from landing to walking, we don't want to use the exit time. We want to exit immediately. And our condition will be if the speed is greater than 0. Alright, so if I'm, bam. Jump, land, walking. Jump, land, walking. Hooray. Pretty easy. You can see the web is getting a lot denser. Now we should also set it up so that we can re-enter the jump state for our double jump. Because right now if we're falling and we jump, I stay in my falling state. Go from falling, we'll transition back to jumping. And all we gotta do here is turn off the exit time and set jumping to be true. And if I jump and then time it so that I jump right as I fall, I can jump, fall, and jump again. Now if I get the timing wrong, it doesn't really fire. So what we can do is add a double jump function. So I'm going to get my jump and then Control D to duplicate it. I'll make this one as double jump. So Mario, jump, and we'll do this one as double jump. There we go. Let's go ahead and right click, go from jump to here. And then we'll make the transition. Let's turn off the exit time. And we'll do our condition. We'll set this as jumping being true. Go ahead and play that. And that works. Now I don't go back into my fall state, so I do need to make sure that I go from double jump back to fall. So our double jump will go back to falling. I'll just move this over here. So to get to double jump, I'll hit jump again. From falling, this is going to be our transition out, so we'll use exit time, and we'll go back into falling. And then everything else should continue as normal. So if I run this again, I can jump and then jump again. Hooray! Ah! Whoo! Aha! Alright, so let's set up some other animations. I've got a bunch over here. Let's see, we've got punch, crouch, and run. Let's do crouch. Bring that one over. There we go. Let's go ahead and right click from idle, go to crouch. Our transition to crouch, we're going to do that as immediate. We want that to happen right away. But I do want to have a condition set. So let's make a new condition. We'll do a bool. This will be is crouching. We'll also make an is punching variable. So is punching. And we might as well make a is running variable as well. So is running. All those are good. Let's get the crouch transition and set the crouch parameter here. So is crouching is true. That gets us to crouch. And then to get out of crouch, we'll go back and we'll set that transition immediate and if crouching is false. Crouching false. We'll save that. Jump back into our code. Let's go to the top And let's add our other variables. So a private bool is crouching false. Let's also set up our punching. So is punching. And then we have our is running. So is running. Alright, let's go into our move player function here. Now realistically, you'd want to separate out your inputs from all of your movement code, but it's fine. We're going to throw it all in here and just call it a day. So we'll call this crouch. And for our crouching section, we'll simply do if input dot get key down. And then whatever key you want, so key code dot, I'm going to use left alt, so left alt. Most people use left control, but my reach is smaller on that hand, so I have to be speckle. Let's go ahead and add on some braces, and we'll just make this is crouching. We'll set it to true. And then the opposite of this will be the else if. So I'll just go ahead and borrow this part. So parentheses. And we want this to be is key up. Awesome. Let's go ahead and make some braces. And we'll do, hey look, IntelliSense knows what I want. Is crouching will be false. Awesome. So key up. So if we press the key down, we do crouching. If we let go of the key, so key up, we uncrouch. Let's go and set the animator value. Let's go ahead and just grab our set bool. And we will make this one is crouching. And we'll set that here as well. So is crouching. Save it. Alright, Alt for crouching, and I let go. Yay! Now I can still move while I'm crouching, which is not ideal. So if I'm walking, I can't even enter crouch, but if I crouch and then try walking, I can still move. So let's go ahead and stop that. I'm going to go back into our code here. Let's go to the top, and we want to be able to set our move speed to 0. And then be able to set it back. So let's make a default move speed. So private float default speed. And that'll be the same thing as our move speed, so I'll do 5F. Good enough. We'll go back down into our crouch function, or a crouch operation, I should say, and we'll set move speed to 0. That'll stop us immediately. And then we'll get our move speed when we uncrouch, and we'll set it back to the default speed. There we go. So I can crouch, and I can't walk while I'm crouching. I'm getting menus because I'm holding Alt, but yeah, I don't walk around, which is good. And then I can let go. So let's go back to the animator. We want to be able to go from walk to crouch. So I'll make a transition. And that'll happen immediately. And if we are crouching, we want to go from crouch back to walk. And then crouch goes back to walk immediately. And that is if our speed is greater than 0 and we are no longer crouching. So crouch will be false. So walking, I can crouch. Let go, I uncrouch. Crouch, uncrouch, crouch, uncrouch. Very good. We can stop that. Let's go ahead and add on punching. There's our punch. It's always fun to throw a punch here and there. So again, we'll go from idle to punching. And I'll get the transition line. I want this to be immediate, and if we are punching, so get the punching value, set it to true, and we will go back to idle, and that'll be, we'll set our condition to use the exit time, so we'll wait for the punch to finish before we can do another punch. So it's going to finish, it'll blend back to idle, but we have to change how our punch is going to reset. So I'll go back into the code here. I'm going to go above my crouch. Let's make a spot, we'll call it punch. So if input dot get key down, and whatever key you want to use. And actually, I want to use the mouse button. So instead of get key, I'm going to do get mouse button down. So get mouse button down, I'll use 0. Just so you know, 0 is the left mouse button, 1 is the right mouse button, and 2 is the middle mouse button. Get some braces here. So when we enter our punch, we got to check a couple things. First, we want to make sure that we're not already punching. So if we are not punching, then we will enter the punching state. So is punching becomes true. We're also going to stop moving. So moving will become 0. Hooray. But when do we reset our punch value? Well, we need to reset the punch value when it is done. So when that animation is finished. So we have to check the animation timing on that. You can make it to where you release the mouse button, but you're going to have some bugs if you do that, because as long as you're holding the mouse button, your character would get stuck. I can show you that, but it would just drag the video out. But go ahead and try it on your own. For us, we're just going to go ahead and make a stop punching section. And we'll do if we need to check what animation is playing. So animator dot, and this is a long one, get current animation state info. And that is a function. Now animation state info wants to take in the layer index. Now we talked about layers a second ago. So if we go to layers, the default base layer is index 0. You can add additional layers to blend different animations together. We're going to skip this, but we just need to know what this is talking about. So base layer is animation layer 0. So I'm going to pass in 0 here. And then we need to know what the name is. So is name, parentheses, and then in there, we're going to look for the name. So the state name in this case is, if we jump back in, punching. Now, remember earlier in the video I said that we're going to rename this to idle and this to walk, because if we need to talk to those actions in code, we want to just be able to say, hey, do something with walk, do something with punching, do something with crouching. It doesn't matter if we're talking to Mario or the default player or Scorpion or Elf Dude. We just want to be able to call punch, not Mario's punch or Elf Dude's punch or Scorpion's punch. So since we need to speak to this name directly, let's go ahead and just really quick fix our animation names. So Mario punch, I'm just going to take off up here Mario's punch. I do want to keep these named, that way I can find them in the file system, but this part on the state machine, we're just going to change those here. So get this one, I'll make that one crouch. So punch, crouch, walk. I'll come over, I'll get Mario's jump, Mario's falling, landing, and double jump. And I think I'll remove the underscore. There we go. And then for running, which we will bring that one in just a minute, let's go ahead and just rename that one as well. There we go. Okay, so now I'm going to just call that variable name, or sorry, that state name. So that is called punch. So if we're in the punch state, and so I'm going to go ahead and just break at the end of that section there. So double and. We want to get the animator state info again. So I'll just grab that line. So animator state info dot. We need to see what the animation current time is. So normalized time. Remember that a normalized value is ranged from 0 to 1. That's all that means. And then we're going to see if that value is greater than or equal to the animator state info length. So it's going to grab the current animation that's playing, and if that value is greater than whatever the length is, then the animation's finished. Personally, I would make a whole new function that grabs whatever state name it is. Right now we're hard coding this value, which isn't a good idea, but for testing purposes, you'll see how it works, and you can make your own functions from there. Go ahead and hit enter, throw some braces on, and then down in here, we're going to say punching is false, and we will put move speed back to the default speed. So default speed. Awesome. Then we're going to go down to our set animator values, and we'll set the bool. So this one's going to be is punching. And then this one is punching. Go ahead and save that. We'll jump back over. Hit play. Okay, I can hit punch, and I punch. And I go back. Now there is a bit of a quirk. You can see that if I punch too fast, or if I punch while moving, I get a bit of a bug that happens. So punching works, and I go back. Punching works, I go back. If I hold down the button, looks like we're good there. If I'm walking, I try to punch, I end up going into my falling state. Let's take a look at what's happening. So if you come over to the inspector and hit this little, you can see there's breadcrumbs here and breadcrumbs here. The upper set of breadcrumbs next to the lock, if I hit that, I can change our setup from normal to debug. And I'm going to get Mario, and we're going to read some values. I'm going to hit play. Scroll on down. Here's our gravity value. Watch what happens when I throw a punch. Do you see how the gravity value flickered? So if I hold down the button while I try to walk, we end up tripping our gravity value, and it goes haywire. It's like, why is that happening? Well, that's happening because of a few annoying things with the current setup. So if you remember, our character controller does not update immediately, right? It samples the world, sets its ground variable, and then says, yep, I'm good. Only on the next movement change does it even check the ground again. So we made it so the gravity would be happening all the time to force our capsule to continuously move and check the ground. This is why most people just use rigid body and just avoid the character controller. But since we're already here, we're going to go back and just adjust the way our gravity is being set. So in here, we are basically storing our gravity value into a variable, and then we pass our variable back into our move direction Y, and then on our move section, when we actually move based on that direction value, we multiply by our move speed and our delta time. What that actually ends up meaning is that this value gets changed based on our default move speed. So if you were to look at this and like right at the math, so if we take a look at the math here, for those of you who don't do vectors in your head, let's say we have a vector. We typically have x, y, and z. I should do this with like a pen pad, you know. And we're multiplying that vector by some value, our movement value, so m, right? And then we also do it by delta time t. But we're going to ignore delta time. Delta time is like some fractional number of like 0.001, blah, 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 something out there. And just for simplicity, I'm not going to do that math here. But that's what we're doing, right? We take our movement vector, which is our direction, and then we multiply it. Now, when you're multiplying a straight vector like that, you're basically just distributing your property. So let's say our vector, when we feed this in, is like 1, I don't know, 2, and then 3, right? We have some numbers populating these positions, and then you multiply across our movement value. Our movement value in this case is 5 times delta time, which we're ignoring, right? So if we distribute this across, we end up getting, what, 5, 10, and 15. Hooray, this is what we end up with, right? Something like that. But the point is, the value that is going to be our gravity value, which is our y, if we're standing on the ground, should always be 0, right? So that means if I move left or right, even when I'm not off the ground, we are modifying our gravity value. If you're doing a game where you don't have to jump, this setup is fine. It doesn't matter. But it would actually be better for us to make sure that our gravity value is ignored when we do our movement code. So we don't want to multiply our movement across our gravity. So what we want is something like this. So our x value, which we're going to multiply by our movement, and of course delta time. So I'll squeeze delta time in here. So there's our t, right? So this would be our x value whenever we push a button. Our gravity value will be handled separately. So instead of being multiplied by the movement and delta time, we'll multiply our gravity by whatever offset value. So I'll just do O for our offset, and then our delta time, right? And then our z value is going to get multiplied. Yeah, this is so difficult to write those. To do the asterisks. Multiplied by our movement, and then our delta time. So this is the setup we need to do for our movement code. That way our gravity value is handled separately from our movement values. That way if we're on the ground and we're moving, our gravity value is basically 0, or in this case it would always be that negative 0.5, because we have to do that little bit of an offset to make sure that we're actually touching the ground. Otherwise we'd be floating or drifting or something. So, but yeah, we need to make sure we separate this out. Let's go ahead and clear this out. And instead of doing move directly on the vector, we're going to do this. We're going to do new vector 3. The first value will be the move direction dot x times move speed times time dot delta time. The next value that has to go in here is going to be our gravity value. So I'll say gravity, and we'll multiply that by time dot delta time. And then we will then multiply our move direction dot z value. We'll multiply that by the move speed, and then by time dot delta time. Okay, so that's a lot longer. I'm going to break this up so we can see it wrapped. So I'm going to go to the first comma and then hit enter so we can wrap that. And you can see that a little bit easier. And you can wrap this at each comma just so you can see what each section is doing. So move speed x times our delta time, our gravity times our delta time, and then our direction multiplied by our delta time. Now, since we're just passing gravity in directly, we can just avoid going into our move direction.y. We can just skip that altogether. All right. So we'll hit stop, save here. We're going to jump back in, and we're going to hit play, and we're going to watch the value. You can see Mario's already doing something silly. Now, if we look at our gravity value, it's jumping between -0.5 and some random thing. The reason that's happening is if we jump back in, before we modified this, it was multiplying our move speed, which is 5, across our gravity value. But we're no longer doing that. This is going to be all by itself so that we can avoid messing with our move speed. Fine, fair, but there's also another problem. If we were to jump, you can see we actually don't jump as high either. So we're going to create an offset value or a gravity weight value that we can play around with to make our gravity not flip out as much and also feel a little bit heavier. So I hit stop, come back in. Let's go back to our top, and underneath our gravity value, let's make a private float. Call this gravity gravity boost. There we go. Make gravity a little bit heavier. And I'll just make that 5. So we'll come back down, and we'll multiply that value here. So gravity boost. Now you could say we could always up the gravity value or up our jump speed. You can do that. I'll show you why you probably don't want to in just a second. So if we save this and play it, there we go. We're no longer flipping out. We can walk. We can throw punches. I can jump. My jumping is normal. I can crouch. All those are working. Now, just to show you, if we take out our gravity boost and instead just modify our jump speed here. So let's say we want to just bring our jump speed up from 3 to 13. If we do that, we get a higher jump, but look how floaty it is. If you prefer the floaty jump, you're welcome to do that. I'm going to dial this down to like 6. So there's our floaty jump. It takes us a little bit of time to get up, and even slower to kind of go back down, which is kind of like a little bit of like walking on the moon, right? But we also end up with the problem of our gravity value is still a little bit too low, and it's not hitting the threshold we need for us to be stopped. So I'm going to set that back to 3, and I'll put the gravity boost back on. But here we go. So gravity boost by our delta time. Hip hip hooray. So our value is no longer flipping out, punching, walking, and our jump works as desired. Alright, let's go ahead and make it so that we can punch while we're walking. So if we're in our walk state, if you see your values like this, that means that we still have debug on. Go over to the top breadcrumbs here, and then normal. There we go. Alright, let's go from walk to punch. We'll make that happen immediately. And we'll go back to punching. True, yes. From punching to go back to walking. And then for our punching, we're going to use the exit time again. But we also want to make sure that our second condition will be our speed is greater than 0. So now if we're walking, we can throw the punch, we'll stop. So if I'm walking, I can throw the punch, I'll stop. And then when I'm done, I'll start walking again. Okay. Now there's a bit of a slide out, and the reason for that is it's trying to blend through the animation. If you hit the drop down here, and then you can set the transition offset. So you can set a value here if you want, but I find it easier just to adjust your sliders. So I'm going to pull my slider on the end here up some. I think about like that is good. Go ahead and hit play. So now I can walk, throw a punch, and then I step into walking. And of course you can play with this value live, so I can shuffle it forward a little bit more and see how much quicker I want to blend into that. So I can keep, bam, I can punch. And you can always play with that duration for idle as well to get a much quicker release time on that. Alright, so there are those. And then the last animation we're going to do for this will be our run session. So I'm going to go from walk to run. Our transition here will be if we are running. So condition, of course the speed has to be greater than 0, but that already happens from our walk, so I think we can skip this one. Let's go straight into running, and we'll say if running is true. And then we do want the transition time. Let's make that immediate. And then to get out of running, we will go back to walk. Take out the transition time, and we'll just say if we are not running. So I'll make that false. Looks pretty good. Let's go ahead and set that up in the code here. Down here for our animator set bool, I'm already here, so I might as well just go ahead and set the value for is running. Oops. So is running. And then above here, I'll do it after crouch. So after crouch is done, I'll make running. Run is good enough. So if input dot, we'll do get key down. For the key code, let's do left shift. Go ahead and make some braces. And for this, we'll simply just do is running true. We'll set our move speed to our run speed. So let's go up to the top here. Do we have a run speed? Default, we do not. Let's go ahead and make a run speed. So private float run speed, and I'll make that 10. You can always adjust that later. Down here, let's make for run left shift, this will be the run speed. And then when we let go of shift, so else if, let's get our left shift key. Oops. Let's copy that and paste it. We'll make this one key up for when we release the key. So draw some braces. Running will be false. And then move speed will be set back to our default speed. So in this case, yeah, default speed. You could always call this walk speed, you know, and you'll have run and walk speed, whichever. But all right, that should do it. Let's go ahead and take a look. All right, so I'm walking, I can run, I can stop running. Whee! Now, of course, I can't enter my jump state from running. I will let you handle that. But, yeah, that looks like it's working. I can't punch from this state. If I try to punch, I will freeze. So you will have to set up your punch for this. but you've already seen how to do it, so I don't think I need to. Go ahead and hit stop and save your work. I think that's going to do it for this video. Hopefully you get a pretty good idea of how to use the visual state machine and kind of connect it through your C# code. In the next few tutorials, we're going to create a more dynamic state machine that is more code-centric and less visual, so you kind of get to see both avenues. But yeah, hopefully you like this, and I shall see you next time. Hey guys, thank you for checking out the channel. If you like that video you just watched, consider hitting that like button and hit or subscribe. Also, if you'd like to support the channel, check out the Wielders of Ether. It's my upcoming comic book. The Kickstarter will be dropping pretty soon. You can see that is getting ready here. The newsletter for that, if you go to brucebooks.com, you can sign up for the newsletter, and you will be notified when the Kickstarter drops. We're pretty excited, and we hope to see you on launch day.